Today we're dealing with lesson 8.5, and you can see rational equations or inequalities. So we're going to still have those same polynomial fraction looks. So they have to be rational. Anything that's rational is a fraction, but they're going to be in that polynomial look. So bis and tris in the numerator and denominators. We're going to solve problems using both equations and inequalities. The equations, I think you will have seen similar problems to it, but I think it's the inequalities that will be the new piece. So here we go, and take a look and see if you do recognize how to handle equations. This first one says solving rational equations and inequalities, but it is definitely an equation. We see the equal sign. So when we say we're going to do these, they're going to contain at least one rational expression. So these ones look like they're basically two fractions set equal to each other. So in this case, if we would solve this, most people would say it sort of looks like a proportion, and we've solved plenty of those. And so we're going to solve that same process, which is the product of the mean. Whoa, that's a little big. The product of the means equals the product of the extremes. And to do that, we want to make sure we're looking at the diagonals. So left upper with lower right, and upper right with lower left. So means and extremes. So it looks like when we do that, we would get, and I'm just going to multiply it right out, x times x minus 1 would be x squared minus 1x. That would have to be set equal to the other diagonal. Looks like 6x plus 18. So go ahead and multiply what you can. Now, looking at this face value, that it looks like it would turn into a trinomial if we got everything to one side. So let's do that and deal with one equation. So we'll leave the x squared here. We like it to be a positive first term. We'll move the 6x over with a subtract 6x, so we'll have a total of negative 7x. We'll bring the 18 over as a negative 18 also. So when we finish, double check, x squared minus 7x minus 18 equals 0. Looks like a quadratic. Before we use the quadratic formula, let's see if we can truly factor it. Be a little quicker than the quadratic formula. So definitely x and x, and then in your brain you're saying what multiplies to give me negative 18 that adds to give me negative 7. It looks like our 9 and 2 should work. So we need an x minus 9 and an x plus 2. If we FOIL that back out, that gives us our x squared minus 7x minus 18. So if we said to solve this thing like we usually do, we're looking for our zeros. So we want x equals 9 and x equals negative 2. Now, as always in equations, you want to put your values back in, at least mentally, to make sure that they do work. And if we put them in, we already had this restriction up here that was basically saying as long as you don't get a negative 3 and a 1, which would make our denominator 0, we should be okay. But if we put the 9 in, 9 over 12, it has to equal 6 over 8. And if we reduce both of those, take a 3 out of both of these, 3/4, take a 2 out of both of these, we would have equivalent fractions. And then doing the same thing with the negative 2, we'd have a negative 2 over 1 has to equal 6 over a negative 3, and obviously the negative 6, or the 6 over negative 3 reduces to negative 2 over 1. So we do get that solution, that check step, and we want to make sure we continue to do that even if it's just in our head, because that's crucial on these. And so if we would check, we got 2 solutions. Did they get 2 as well? They did. Okay. Now remember, this was for if we had 2 fractions, 2 rational expressions that were equal to each other. No extra pieces, so it looks like 2 fractions. We could do means and extremes. Next one. Well, definitely not means and extremes. In this case, we're looking at 2 fractions that are subtracted, and they have to be equal to this third fraction. So it just looks like addition and subtraction of fractions really basically going on. Now the problem is we have three different denominators. We've got our quantity of x plus 2, our quantity of x plus 2 here in the first one. And we have the factors x squared minus 4, which we really should know by now is x plus 2, x minus 2. And then we have the third one. So if we're looking at trying to add and subtract fractions, as the rule has always been, let's get a common denominator. In this case, better yet, let's get rid of the fractions. But the only way to get rid of the fraction is by multiplying by that greatest common denominator, so or least common denominator. So it looks like this guy needs an x minus 2, this guy has them both, this guy needs the x plus 2. So if our common denominator right now is the quantity of x plus 2, x minus 2, that's what we're going to multiply every fraction by and make it that many times bigger. So with that, I'll do that on top. If I did that here, x plus 2, x minus 2, and here on the last one, x plus 2, x minus 2, okay? And we canceled what we could. Now be careful because it does get a little messy here. We'd have the x and the x minus 2. So before I start canceling everything, I'm just going to go ahead and multiply that out so I don't get it confused. So x times x is x squared. X times a negative 2 is negative 2x. Then we've got a minus sign, but let's do the canceling first. Well, this one, everything cancels. So all we have left is that subtract 8. Then we've got equals over here. The x minus 2 cancels with the x minus 2. So we have a 2x plus 4 remaining. Okay, again, taking a picture snapshot of it, it looks like if you move everything to one side, we should be able to get a quadratic. So let's go. No fractions remain, which is nice. X squared, if we bring the 2x over to the left-hand side, we'd have a negative 4x. We already have a negative 8, but if we bring the 4 over, we now have a negative 12 also. That would all be equal to 0. So x squared minus 4x minus 12 equals 0. Again, let's try to do factoring. It's a little quicker than quadratic formula if it works. X squared minus 4x minus 12. So what multiplies to give me the negative 12 that adds to give me the negative 4? Looks like a 6 and 2 is going to do it in this case. And then find your zeros. What makes me 0? The first parenthesis is that positive 6. What makes the second parenthesis 0 would be that negative 2. Okay? Now, let's check again, as we said. And we can already see, hopefully, that there's a problem with one of them because we never had restrictions on this one like the last one. But you can see what's going to make this first denominator 0. A negative 2 will. If we have a 0 in the denominator, we have an impossible solution. So I think we're going to have to eliminate that negative 2 as a solution because it's one of our zeros. And then double check with the 6. And so our check work would be 6 over 8 minus 8 over 6 squared is 36. Take away 4 is 32. Two fractions we're going to have to reduce. And then 2 over 6 minus 2 is 4. All right, here we go. Let's reduce everybody. 6/8, better known if we take a 2 out of each, 3/4. If we take a 8 out of numerator and denominator here, we would get 1/4. And we can see that we have a true statement just by looking at that without even reducing. 3/4 take away 1/4 is 2/4. It checks. We're good. Our solution of 6 is what we have. And I believe that's exactly the solution you saw up here. Yep, exactly what we did. Okay, now, what you have to remember is if you don't take that extra time, you are not checking for those extraneous solutions. We've talked about this before earlier in the course, that if you have numbers that look like they're good, 6 and negative 2, and you really don't check back in the original problem, you are probably going to have some ones that make it false that are not true, and obviously they would cause problems with your final answer. So remember to check whether it's mentally or on paper like we've done, your solutions. All right. Next, So that was fractions, take away fractions. We got rid of the decimals, or we got rid of the fractions. Now, this one's going to be a slightly different. We're going to switch to our inequalities. No more equations. And when I look at this one, it looks a lot like that first one that we did with the equations. We had a fraction on one side, it was rational, and we had a number on the other. We could set it up and make it look like a proportion, and we probably will. But the problem here is we have variables in the denominator. So really, we need to consider two possibilities, because we do not know right now. Is that x value, or that x minus 3, that whole expression in the denominator, is it a positive number, or is it a negative number? So in an inequality, we're going to have to take into consideration both things. So let's do them one at a time. Let's do the positive first. So we got our original equation. If we consider our x minus 3 to be positive, then we're looking at this just like we did the proportions a minute ago on the other ones. And we're going to do our cross products. Okay, and I think that's exactly what you're going to see here. 4x is less than or equal to 6 times the x minus 3. Go ahead and multiply it out. You would get 6x minus 18. We'll move the 6x over to the left-hand side here and get the negative 2x is less than negative 18. We divide by a negative 2, and anytime we divide by a negative 2, we must switch our inequality sign. So we get a solution to the inequality of x is greater than or equal to 9. But here's the and part. We need to also consider that our denominator of x minus 3 is positive. Well, if it's positive, it means it has to be greater than 0. So solve this simple statement that says x minus 3 is positive, greater than 0. That puts us at x is greater than 3. And so now really we have two things to consider. We have the x is greater than or equal to negative 9, and the x is greater than 3. But remember, when we graphed and statements, two choices, we always were looking for their intersection. So if we do a quick mental image of all the x values greater than 9, we'd have a closed circle here and everything to the right. If we did the same thing for the x values greater than 3, well, that would be an open circle and everything to the right. But again, where do they intersect? They only intersect from that 9 value on. So our solution for when x is greater than 3 or positive has to be x is greater than or equal to 9. It's the only statement that works for both situations. So if we did that same thing, but now considered x as negative, it's going to be similar, but you will see slight differences. So let's start again thinking, okay, it's like a proportion, so cross products. But the only problem, remember, x minus 3 is a negative, and you got to keep that in the back of your mind. So when we do 4x times 1, we're fine. 6 times x minus 3 is still 6x minus 18, but because we were multiplying by a negative number in an inequality, you must switch your inequality sign. So we switched it to greater than or equal to. Now we start manipulating, moving things over like we did before. 6x comes over as a negative 6x. We'll have negative 2x is greater than or equal to negative 18. We'll divide by that negative 2 again, which will switch our inequality sign. So x is less than or equal to 9. That's for the equation part. But now again, think about what you're proving or solving for. X minus 3 is negative. Well, if x minus 3 is negative, that means x minus 3 is less than 0. So we solve that situation, and we have to take into consideration x is less than 3. So again, in your brain, or quickly graph, which I've done here, graph all the x values that are less than 9. Well, that would be a less than or equal to 9. It would be a closed circle at 9, everything to the left. Then if we graph all the x values that are less than 3, that would have been an open circle at 3 and everything to the left. So again, where is the repetition? The repetition is from that 3 on down. So x is less than 3 was our final answer to when x minus 3 is negative and x is greater than 9 was our answer for when x minus 3 was positive. So as we say here, that final answer has to consider both of those things, and that's what you're seeing down here. Okay? So that would be a little different look, but it uses the same process as we used. You just have to remember, solve it once for the denominator being positive and once for the denominator being negative. And you will have a series of answers, not just one number, one solution. Okay. Next, if we were to give you just an inequality that had two denominators, each of them being a rational, or each denominator being a variable in it, that would then mean now we'd have to assume, wait, what if x minus 1 is positive? What if x minus 1 is negative? Well, what if x plus 4 is positive? X plus 4 is negative. You've got lots of choices. So take a look here. In order to clear the inequality of fractions, you can multiply that at least common denominator, which we did before. But you still have to consider all four possibilities, and you don't know which one you really have. So therefore, the algebraic method is not covered in our course, but with our graphing calculators, the solution is much easier to find. So keep in mind what our equation was. We have two fractions. They are rational because of the x minus 1 and x plus 4 involved in them. So that's what you're going to see here. There is our original inequality. We will first rewrite it and put everything on one side. So we have a fraction subtract the second fraction. But then if we're going to graph, think about this. We could set this new statement that we found equal to y. And so then, once we find out what that graph looks like, we know we have to find the values which are really greater than 0. So find the graph of 2 over x minus 1, subtract 3 over x plus 4, find the values for that which that entire graph is greater than or equal, just greater than 0, because our sign is just greater than here. It is not an or equal to sign. So I would like you to take a look at our graph of this. You can use your grapher and try it. Be careful because you are going to have to put some extra parentheses in probably. It would probably be good if you were taking your grapher to graph it in or type it in like this, y equals, and put extra parentheses on that fraction, the parentheses for the denominator, and then the parentheses for the fraction. So just be careful how you get your solution in. Now, when we do graph it, whether it's on a graphing calculator or online, we get an equation that, again, goes with some of them that we've seen that have been very strange graphs. We have this parabola-style shape down below, and then we have these two hyperbola looks up top. And as you can see, we don't have it marked here, but it is very clear that we have an asymptote at -1. So I'll put the dashed asymptotes in. And we have another asymptote at -4. Vertical asymptote, that is. Okay? And so from here, going back to the question that was asked, we want to think about when is this graph greater than 0. So your eyeballs are basically looking from the x-axis on up. When is our solution? When are the y values greater than 0? So right now you're going to have to say, well, let's see, it's only over here and over here. So we would want to say when x is less than -4 works, and when x is greater than 1 is a solution. So you would have the graph as your verification, and then you would be able to write your solution without having to test that positive-negative situation. Okay, now let's go back to the actual problem and check our solution, because think we're about done. Yep, x is less than -4 or x is greater than 1. So when you put this into retrospect, we've done really 2 style of problems each time. Once for equations, we had the proportion look. Then we had the 2 fractions on each side of the equal sign. So we had a situation where it was more addition and subtraction. We used the least common denominator to get rid of the fractions. That would be simple here, but we got the problem because of the x minus 1 and the x plus 4 in our denominators, not giving us specifics about, okay, is that going to give us a positive answer, or is that going to give us a negative answer? And with that, we don't have the method, but we do have the idea of using our grapher, being a little more visual. And for some of you, that would be better than even doing the arithmetic. So with that, you want to definitely watch out for the different styles of equations and inequalities you're given. But I think you should be good to go, and bring any questions you might have with you to class.